Welcome everybody, it's Miss Parsons for Algebra 2. Today we're talking about Skill 26, the properties of logarithms. We're going to go ahead and jump right in. So the first property is the product. Remember, product is multiplication, and that says that the log base a of x times y can also be written as the log base a of x plus the log base a of y. Then we have the quotient. Remember, that quotient means division, property of logs, where we have the log of a of x over y is the log base a of x, not plus anymore. This is now minus log base a of y. So how I remember this is product, multiplication, and addition always mean that the number or the quantity is getting bigger. Okay, so those are related. Here, quotient, division, and subtraction. Anytime I divide or subtract, a number gets smaller. So that's just a little way in my head that I remember that those go together. So then I have a power product. So anytime that I have a power, so in this case, I have a power of y. Okay, so to rewrite that, it walks across the log and goes out in front. So this is y times log base a of x. So that power walks across the log. So we're going to use these three properties to expand and condense logs. So let's look at this. 31. Still going to use black. So here I have 3x. That is multiplication there in the middle. So I'm going to use my product property. So it's a log base 6 of 3, and it's not multiplication. We're going to use the addition, log base 6 of x. Okay, so see how that works there? We are expanding it by using that property that says multiplication. We can rewrite as adding those together. Here on 32, I have division. So remember, division isn't addition, it's subtraction. So to expand this, I have log base 2 of x minus log base 2 of 5. Okay, pretty easy so far. But now what happens when I start combining these? Okay, so I've got some multiplication on top, but I also have the whole thing being division. So let's take it one step at a time. Let's talk about the division first, because that puts me at log base 4 x times y, my numerator, minus log base 4 of 3. Okay, so taking my numerator minus my denominator. But here I still have multiplication, so I can expand that even more to be log base 4 of x plus log base 4 of y minus that log base 4 of 3. Okay, so now we are all expanded. In 34, okay, I've got a few things going on here. Okay, let's talk about the multiplication we've got going on here first. So I can expand that to be log base 5 of 2 plus log base 5, the square root of x. Okay, but the square root of x, we're going to rewrite that. Okay, remember your power over root, so we can write it as a rational exponent. That's x to the 1/2. Okay, So if I erase this all and wrote it as x to the 1/2, I can use that third property that tells me that this exponent is going to walk across my log out in front. So log base 5 of 2 plus 1/2 log base 5 of x, where that exponent walks out in front on the log. Okay, let's try some challenge ones. Okay, the first thing I see here is this x that is in the the fourth root of x. Okay, so remember that can be written as x to the 1/4. Okay, y over z squared. So let's rewrite that. Log base 3 x to the 1/4 y over z squared. Okay, so I've got multiplication up here in the numerator. Down in the denominator, I have z squared. So let's see, that's going to be log base 3 x to the 1/4 y minus, because of the division there, log base 3 z squared. Now we're going to use that power property of logs. Well, the first thing we have to do before we do that is we have to actually split this up as well. So let's split that first. Log base 3 x to the 1/4. Okay, it's multiplication, so I have plus log base 3 of y minus log base 3 of z squared. Okay, so now I'm going to worry about these exponents using the power property where they walk across the log. So I've got 1/4, because it's walking across the log out in front, log base 3x plus log base 3y minus, forgot to walk it across the log, 2 log base 3 of z. Okay, so now that's all expanded, and I used all three properties. Okay, on this next one, I have three things being multiplied by each other. Okay, so remember, I'm going to use that product property, which tells me that I can rewrite it as addition plus log base 8 of x squared plus log base 8 of y. Now I can use one other property here with my exponent, which tells me it's going to walk across the log out in front. So I have log base 8 of 5 plus 2 log base 8 of x plus log base 8 of y. Okay, so now I want you to pause the video and I want you to try numbers 1 through 3. All right, these should have been your three solutions, log base 6 of u minus log base 6 of v, using that quotient property. Here you had a times b cubed, so that was the addition, but the 3 was going to walk across the log. Okay, 3 was a little bit more challenging, so I wrote the square root of x times y as x times y to the 1/2. So I knew that it was going to walk across the log here. So you should have got log base 9 of z plus 1/2 log base 9 of z plus log base 9 of y, with the 1/2 out in front of both of these, since that 1/2 applied to both of them in the beginning. Let's jump back to our notes. I can also use these properties to condense my expressions as well. So if I look at 35, I have a minus sign. So you should be thinking, oh, okay, well, minus means quotient. So I'm going to take that log base 3. The 7's going to become my numerator, and the x is going to be my denominator. Okay, easy squeezy lemon peasy. All right, 36. I've got 2 log base 5 of x plus log base 5 of 3. Now you see that addition sign, so you should be thinking, okay, there's some multiplication going on here. But what about this 2 out in front? Well, remember that 2 walked across the log, and it could be placed up here to be an exponent. So I have log base 5 of x squared times 3. Okay, and 37, that 1/2 out front is going to walk back across the log to become an exponent. The 3 is going to walk past the log and become an exponent. And we know this minus sign in the middle means division. So I have log, and there's no base there, so we know it's a base 10, x to the 1/2 over y cubed. Okay, and I'm going to rewrite that one more time because x to the 1/2 can actually be written as the square root if we wrote it as a radical. Okay, so that's my final solution there. Okay, here to condense this, I have some addition, so that means multiplication. I have some subtraction, so that means division. So let's put this all together. I have log base 3 of 4 times x, okay, but I've got this 2 out in front, so that's going to walk across the log and become an exponent, divided by 5. Okay, let's look at these challenge ones, which aren't too bad. Same things applies. I got the addition sign. I've got a subtraction sign. I've got a couple coefficients out in front that are going to walk across my logs here. So this is going to become log base 3 of x to the 2/3 power, y to the 4th, multiplication there because of that addition sign, divided by z. I'm going to rewrite this one more time as a radical because this 2/3 can be written as a radical. Remember your power over root. So log base 3 x, 2 is my power, 3 is my root, y to the 4th over z. Okay, b is actually pretty simple. I've just got a minus sign there, so you're thinking division. I've got a 7 that's going to walk across. I've got a 3 that's going to walk across and become an exponent. So that just becomes log base 7 of h to the 7th divided by j to the 3rd. All right, go ahead and pause the video here and try the U-tries number 4 through 6. All right, and here are the solutions that you should have found. For 4 and 5, those were pretty easy. 6 can be a little confusing because you have all those 2's in the denominator. So I pulled out a 1/2 out of everything, okay? So then I did log base 5 of x times y times z, since we had all addition, walked the 1/2 all the way across the log, And since it applied to all of them here, it applies to all of them here as well. So it becomes log base 5